this figure here takes our big right triangle with the altitude, and there's a whole bunch of letters on it, okay? But what this does is it breaks it down. ABC is our big triangle, okay? Right here, ABC. Then we're looking at triangle ACD, okay? And it rotates it so that these two are in the same position. And then it does the same with CBD. Takes this triangle on the right and rotates it so that now all three of our triangles are in the same position, and it's a little bit easier to tell which triangles are similar to each other, okay? Now, we are going to be using these letters for different reasons, okay? But we're going to separate these. There's two different proportions that I want you to consider, okay? We have a heartbeat proportion and we have a Nike swoosh proportion, okay? You are going to need to be able to tell when to use which of these proportions, and we'll talk about that when we get to some examples, okay? But the geometric mean and altitude theorem is our heartbeat proportion, okay? If you think about when someone's at a hospital and they're using, or their heart rate is being monitored, on a machine, it's going to go boom, up, back down, and then keep going. And it's just that over and over and over again, okay? So if you were to pick this up and move it to this triangle here, this is our big right triangle with the altitude drawn in, okay? We don't even need to worry about the A, B, and C from this picture up here. All right, we're just looking at part to altitude. Okay, this pattern is going to help us write our proportion. Part to altitude equals, okay, and then we go back down, we travel the altitude again over part. Okay, the altitude drawn to the hypotenuse is the geometric mean. Okay, so whatever the length of that altitude is shows up twice in our proportion. Okay, so the altitude drawn to the hypotenuse is the geometric mean. Between the two segments the hypotenuse is separated into. All right, so if you think about that path that a heartbeat takes on that machine, you're taking that same path and say part over altitude equals altitude over part. Okay, and that's why this is our heartbeat theorem, or our heartbeat proportion, okay? Now, our geometric mean, the leg theorem, okay, now we're talking about the legs of the right triangle, and remember, the legs of the right triangle are the two sides that make the right angle. So I'll go ahead and label those. We've got two different legs, so I'm going to write two different proportions, okay? It says the length of a leg of the triangle, okay, so the length of that leg is the geometric mean. So since the length of that leg is the geometric mean, that appears twice in our proportion, okay? And it is the geometric mean between the portion of the hypotenuse adjacent to the leg. Remember, adjacent means next to. Okay, so the portion is just a part of the hypotenuse that's next to the leg. Okay, so in this instance, it's going to be x. X is next to this leg. Okay. And the entire hypotenuse, or the whole length of the hypotenuse, C here. Okay. Now, this is the Nike swoosh proportion, okay? If you think about what a Nike swoosh looks like, boom, okay? And I start at X. I start at X, I go around the corner to B. All right, I travel back down B and across the whole hypotenuse. That kind of resembles a Nike swoosh if I were to finish it, right? Okay? So part around the corner to the leg, back down the same leg and across the whole hypotenuse. Okay? One thing I like to say is this leg is on the left side of this triangle. We want to put our left shoe on our left leg. Okay, so we need to stay on the same side of the altitude when we start. Okay, and then we travel across the whole hypotenuse. So it's the same thing, except now we're going to be on the opposite side of the altitude. Okay, the length of the leg is the geometric mean between the portion of the hypotenuse adjacent to the leg and the entire hypotenuse. Okay, so again, if we're going to write our proportion, we start at the part. Okay, consider this like your right shoe. Your right shoe goes on your right leg. And then we travel back down that leg and across the whole hypotenuse. So kind of a fat one on this, but it still semi-resembles a Nike swoosh. Okay. So we're going to jump to some examples now. Okay. When to distinguish between using the heartbeat and the Nike swoosh proportion. Okay. Anytime you have something attached to the altitude, okay, the altitude is inside the triangle for this. Your heart is inside your body, so you will be using the heartbeat proportion. Okay, which means you're using parts of the hypotenuse. All right, so on these first three here, we have something attached to our altitude. So on all of these, we use our heartbeat proportion. Okay, so we'll try number one. Okay, in our proportion, that altitude is what appears twice. Okay, we start at a part. We go part, and here I'll grab a colorful pen so we can see how this works a little bit better. Okay, part over altitude equals altitude over part. Okay, and that's the order that we write our proportion in. Okay, we traveled across the 7, went up the altitude, back down the altitude, and crossed the 9. Okay. Number 2 here. All right. Remember, part and part is what we need. Right now I have a part and I have the whole hypotenuse. Okay, so the first thing I'm going to do, I'm going to say, well, hey, 25 minus 9 is 16. So this second part is 16. Okay. And if you have to turn your paper, that's fine. I will turn my paper to draw this heartbeat. Okay. We start here, we say part, altitude, altitude, part. Okay, so I started at the 9. I said 9, and then travel up my altitude, which is x, back down my altitude, which is x, and then across to 16. Okay. Example 3 here. I'm going to turn the paper again so that you can see the heartbeat path that we're taking. Maybe. Okay. Part, altitude, altitude, part. Okay. This one's a little different because our x is not on the altitude. Our x is actually one of the parts, okay? But that doesn't change how we're going to set up our proportion. Okay, I started at 36, went from 36 up the altitude, which is 48, back down the altitude, and across that last part, which is just x. Okay, so whatever, in all three of these examples, whatever that altitude is, that's what appears twice in our proportion. Okay, diagonal from each other. That is, the altitude is our geometric mean. Okay, final answers for this one, x is 3 square roots of 7. Here, x is 12. And over here, x ends up being 64. Okay, still cross multiplying and dividing like we've done all chapter. Okay. Now this time, anytime we have something attached to a leg, okay, shoes go on our feet, which are attached to our leg, okay, and in these, we don't have anything on the inside. All right, so nothing on the inside means that's not the heartbeat, okay, but think about, this is a leg of the triangle. Shoes go on our feet, which are attached to our leg, so maybe you can make that connection there with Nike makes shoes or sweatpants, which they go on your legs, okay? So I'll write that down here, something. All right, remember, with our Nike swoosh, we need a part and the whole hypotenuse. So part and whole. Okay. Now, this first one, I'm going to turn the paper. Okay, so we're looking at this the same way that we did on the front side of the notes. Okay, we always start at the part that is attached to the leg we know something about. Okay, since x is on this side of my triangle, my altitude, I'm going to start on that side of my altitude as well, just that part. Okay, so 9, I go from 9 up the leg to x, back down the leg and across the whole hypotenuse. Okay, so if I'm writing that as a proportion, that becomes 9 over x equals x over 25. Okay, that leg is the geometric mean. It appears twice. All right. Number 5 here, I have 2 parts, but remember with our Nike swoosh proportion, we need the whole length here. Okay, so 36 plus 45 is 81. Okay, and now I have 2 choices to start at, but remember, since x is on this side of my altitude, I want to start on that side of my altitude. Okay, so again, I'm going to turn the paper so I can see my Nike swoosh. Okay, I said I was going to start on this side, go around the corner, put my left shoe on my left leg. Okay, back down and across the whole hypotenuse. Okay, so when I flip back around, I said, hey, I'm going to start at 45, go up the leg to x, back down the leg, and across the whole hypotenuse. Okay, and finally for number 6, here, now I don't have an x, but I have a 60, okay, and 60 is on the left side of my altitude. I'm going to start on the left side of my altitude. Okay, my left shoe goes on my left leg, left foot, I guess. Okay, so part up the leg, back down the leg, and across the whole hypotenuse. Okay, so when I turn back around, I said, hey, I'm going to start at 36, go to 60, and then 60 over the whole hypotenuse, which is x. Okay. X in number 4, oh, you can't see that, is 15. X here is not a very nice number. 60 point, we'll say 37. Yikes. And X in number 6 is 100. Okay. So now, in examples 7, 8, and 9, okay, you will use both Nike Swoosh and Heartbeat to find these variables, X, Y, and Z. Okay? Remember, whatever's attached to the inside, you will use the heartbeat to find, because your heart is inside your body. Whatever's on the outside, okay, shoes are on the outside of your body. They go on your feet, which are attached to your legs. Okay, so anytime you're finding a leg, you will use the Nike Swoosh. All right, so try 7, 8, and 9 on your own, and you can check your work in the completed notes.